In this video, we learn moment generating function of geometric distribution. Let us see. This video, we learn about moment generating function of geometric distribution. Suppose capital X be a random variable following the geometric distribution with parameter p. We define capital X as a random variable which follows the geometric distribution with parameter p. Then the probability mass function of geometric distribution is given by p of x is equals to q power x into p, where x is equals to 0, 1, 2, and so on. So x is a random variable following the geometric distribution with parameter p, and its probability mass function is given by p of x is equals to q power x into p, where x is equals to 0, 1, 2, and so on. We know that by the definition of moment generating function, we have mx of t is equals to expectation of e power tx. Mx of t is equals to expectation of e power tx. That is the definition of moment generating function. The moment generating function of a random variable is always denoted by the symbol mx of t and defined as expectation of e power tx. Expectation of e power tx. That's it. So expectation of e power tx is equals to summation x is equals to 0 to infinity e power tx into p of x. E power tx into p of x. What is p of x? P of x is nothing but the probability mass function of the geometric distribution. P of x is nothing but probability mass function of the geometric distribution. Substitute it, you get q power x into p. So right here summation runs over x. So we write p outside the summation. Summation x is equals to 0 to infinity q e power t whole power x. Q e power t whole power x. Remove the summation. I mean expand the summation. So by putting x is equals to 0, we get 1. By putting x is equals to 1, you get q e power t. By putting x is equals to 2, we get q e power t whole square, and so on. This is nothing but the series expansion of exponential function e power x. So remember that the series expansion of the exponential function e power x. By applying this one, you get p divided by 1 minus q e power t. P divided by 1 minus q e power t. That's it. So that is nothing but moment generating function. Therefore, mx of t is equals to p into 1 minus q e power t whole power minus 1. Mx of t is equals to p into 1 minus q e power t whole power minus 1, which is known as moment generating function of the random variable capital X. Oh, I'm sorry, I wrongly interpret that. Here it is the expansion of e power x. I'm very sorry. That is not the expansion of e power x. That is the expansion of 1 minus x power minus 1. 1 minus x power minus 1. I'm very sorry. That is the formula. That 1 minus x power minus 1. What is the formula for this expansion? I mean binomial expansion for negative index. I'm sorry, that is not e power x expansion. That is binomial expansion for negative index. 1 minus x power minus 1. Please make a note there. So 1 plus x square plus and so on up to infinity. Instead of x we have q e power t. Instead of x we have q e power t. That's it. Therefore, the moment generating function of the geometric function is given by p into 1 minus q e power t whole power minus 1. So in the same video, we learn about probability generating function. I mean PGF of geometric distribution. The PGF probability generating function of geometric distribution is given by px of t is equals to expectation of e power tx. Px of t is equals to expectation of e power tx. So that is nothing but summation x is equals to 0 to infinity t power x p of x. So which is equals to summation x is equals to 0 to infinity t power x q power x into p, because p of x is a probability mass function of the geometric distribution. So now substituting that one, you get q power x into p. Now write outside p, outside the summation. Now write the p outside the summation because it is independent of x. So we get summation x is equals to 0 to infinity qt whole power x. This series expansion, summation x is equals to 0 to infinity qt power x is nothing but 1 minus qt, 1 divided by 1 minus 1 divided by 1 minus. This is a geometric progression. This is a geometric progression, or but you can use the 1 minus x whole power minus 1 expansion. 1 minus x whole power minus 1 expansion, as you said earlier. That is, this series expansion is nothing but 1 minus x whole power minus 1. By using that fact, you can write 1 minus qt whole power minus 1. Therefore, the probability generating function px of t is given by p divided by 1 minus qt, or p into 1 minus qt whole power minus 1. That's it.